One of my favorite parts of this class is right triangle trig. This is a lot of fun. It's kind of like solving a little puzzle. So our learning objectives, and I get tired of writing learning objectives, so LOs, are to list exact trig ratios for an acute right triangle and to solve application problems. First thing you need to do is to memorize the ratios. And the important ones are the ones that we have in bold there. And we call it SOHCAHTOA. SOHCAHTOA. Because sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And there are some little mnemonics to help you remember it. Some old hippie caught another hippie tripping on acid. I use that one sometimes just because it makes me laugh. But let's draw our triangle. And this PowerPoint has your angle as T. A lot of times it'll be labeled theta. A lot of times it'll be labeled A or B, but it doesn't matter. You look in relationship to the angle you're evaluating. So the one straight across from it is called opposite. Just like the one opposite the right angle is the hypotenuse, and the one right next to the angle that you're talking about is adjacent. So sine of t is equal to opposite over hypotenuse. Cosine of t is adjacent over hypotenuse. And TOA, tangent, is opposite over adjacent. And remember, your reciprocal identities say that tangent of theta, or any angle, is equal to sine of theta over cosine of theta. So if we looked at our triangle ratios, then sine would be op over hypotenuse. Write the right thing. Hypotenuse. Cosine would be adjacent over hypotenuse. And when you did the fraction arithmetic, you would invert and multiply. You would end up with opposite over adjacent. So it works. Cosecant, tangent, and cotangent. Remember, cosecant is 1 over sine. Cosecant of t is 1 over sine of t. So flip it. Hypotenuse over opposite. Secant is 1 over cosine. So flip it. Hypotenuse over adjacent. And cotangent of t, got to have an input, is 1 over tangent of t. Flip it. Adjacent over opposite. Oh, and here are your reciprocal identities. Cosecant is 1 over sine. Secant 1 over cosine. Cotangent 1 over tangent. So let's start with a nice friendly example where all of our numbers are given to us. So this is example 1, and I'm going to go ahead and draw the triangle just because drawing it myself kind of helps me get it into my head. So this time my angle is named alpha. That's the Greek letter alpha. So sine of alpha is equal to opposite over hypotenuse, 8/17. Cosine of alpha is equal to adjacent over hypotenuse, and adjacent is 15/17. And tangent of alpha is opposite over adjacent, 8/15, not 17. Opposite over adjacent. We could do the rest. We could do cosecant, flip sign upside down, or hypotenuse over opposite, secant, adjacent, hypotenuse over adjacent, hypotenuse 17 over adjacent 15, and cotangent, either adjacent over opposite or just flip tangent upside down. So here's the pretty answer. Exact same thing we have. Use the triangle to evaluate each trig function for angle A. So try this one on your own. You notice that something is missing, but you know how to find it because you know the Pythagorean theorem. So how did it go? First thing I did was find the length of the hypotenuse, and I like to label them all once I do that. I put it into my calculator, and my calculator was nice enough to give me a simplified radical, which is what WebAssigned would want from you, and it's what I would want from you. If it doesn't do that, then you could look at, well, I look at this and I think, well, 4 goes into both of those things, and 4 is a perfect square. So 4 times 25 plus 16. So I can divide this into 4, square root of 25 plus 16, which gives me 2 times the square root of 41. And that's as good as it gets. You would think since those are both squares, perfect squares, it would be better, but it's not because of that plus sign in there. And then I just did opposite over hypotenuse, simplified it, adjacent over hypotenuse, simplified it, opposite over adjacent, simplified it, cosecant, I flipped it, secant, I flipped it, cotangent, I flipped it. Now let's talk about special right triangles. I'm going to start with the 45-45. So if we have a 45-45 right triangle, since these angles are the same, the sides opposite have to be the same. So I'm going to name them S. Well, if this side is S and this side is S, then hypotenuse has to be equal to S squared plus S squared has to be equal to the hypotenuse squared. So 2S squared is equal to the hypotenuse squared. So the hypotenuse has to be equal to the square root of 2 times S. So square root of 2 times S. You can memorize that and use it as a rule. Now let's think about the 30, 60, 90. I'm going to sketch an equilateral triangle so we can understand why it works. So here's my equilateral, and we're going to pretend that I'm drawing an equilateral triangle. I'm using a ruler to do the best that I can. Now, equilateral triangle. That means every angle is 60 degrees. That's not a right triangle. But if I drop a line from the tippy top of my equilateral triangle to the bottom, now I have a right angle, and this angle up here at the top is 30 degrees, or pi over 6, and 60 degrees is pi over 3. So let's name this side S, and this side would have to be 2S because we took this bottom half and chopped it in two, because I'm calling all of the sides 2S. They all have to be the same as equilateral and equiangular. And just so I didn't have to have a fraction in there, I made the sides length 2S. That way when I chopped it in half, this side is S. Oh, the hypotenuse is 2S, but I can figure out what this other side is. We'll call it Y for right now. Y squared plus S squared has to be equal to 2S squared. So Y squared is equal to 4S squared. Subtract the S squared from each side. Y squared is equal to 3S squared. So Y is the square root of 3 times S. Square root of 3 times S. So you can memorize those relationships and use them, and you don't have to derive them every single time. Now, general guidelines for using right triangle trig. Given a right triangle and the length of one side and the measure of one acute angle, you can find the remaining sides. For each side, select the trig function that it has the unknown side as either the numerator or the denominator. The known side will in turn be the denominator or the numerator. So you figure out what you know. Write an equation setting the function value of the known angle equal to the ratio of the corresponding sides, and then solve for what's missing. Makes sense when we try it. So we have a right triangle. And this works with special triangles because we know these relationships. I always like to draw my triangles. I don't always make the effort to get my ruler out. Example 2. So I put my right angle in the corner here. We're calling this one 30 degrees. So this one has to be 60 degrees. Now, because of these special relationships, suppose that S was equal to 1. And we'll just look at the 30, 60, 90 triangle. So here's my 60 degree angle. Here's my 30 degree angle. There's my right angle. So I'm calling this 1. That means this opposite over here would have to be square root of 3. And then the hypotenuse would have to be 2. So sine of 60 degrees is equal to opposite over hypotenuse. Cosine of 60 degrees is adjacent over hypotenuse. Tangent of 60 degrees is opposite over adjacent. You're going to learn that on the unit circle, but that's how I like excuse me, to solve my triangles. So I have A lives right here adjacent to the 30 degrees. C is the hypotenuse, and 7 is the opposite. Well, I know that for a 30 degree, and I should have solved for 30 instead of 60 degree, but that's easy. Let's look at the 30 degree. Sine of my 30 degree angle would be opposite over hypotenuse. So, sine of 30 degrees is equal to opposite over hypotenuse, which has to be equal to 1/2. So if 7 over C is equal to 1/2, I can cross multiply. C has to be equal to 14. Now I could have gone ahead and used those trig functions I had already written. It's okay. Let's figure out what A is. We have some options here. I could go back and use sine of 60 degrees. You see that sine of 60 degrees is opposite over hypotenuse. So sine of 60 degrees is equal to A over 14, and sine is equal to square root of 3 over 2, sine of 60 degrees. So 2A is equal to 14 times the square root of 3, and A is equal to 7 times the square root of 3. There we go. And it matches my 30, 60, 90 right triangle with S, 2S, and square root of 3 times S. So if you had all those memorized, you were already ready already. And there's the pretty answer. Tangent of 30 degrees is 7 over A. Sine of 30 degrees is 7 over C. So C is 14. And A is about 12.1. And if you plug it in your calculator, we have, clear everything, 7 second square root of 3 equals, and it says 7 times the square root of 3. But if I press that little button right above it, it gives me the decimal approximation. If WebAssign wants exact, then you know they want 7 times the square root of 3. If WebAssign wants a decimal approximation, then you know how to do it. Okay, try this one on your own, then we'll come back and compare answers. So we have the no calculator problem to prepare you for test 1, because you won't be allowed to use a calculator for test 1. So we've memorized sine of 60, cosine of 60, tangent of 60. Hopefully, we've also memorized cosine, sine of 30, cosine of 30, the square root of 3 over 2, and tangent of 30, because remember 30, here we have adjacent over hypotenuse, and then we have opposite over adjacent, so 1 over square root of 3. So we can use those when we solve things, but we're using the 60 degree angle for this one. So 60 degrees sine is equal to opposite over hypotenuse. We use that to figure out what C is. Now that I've figured out what hypotenuse is, I could have used cosine, but I went ahead and used tangent, which is opposite over adjacent, because tangent of 60 degrees is equal to the square root of 3. I personally am not offended if you leave radicals in the denominator. if you need to rationalize your denominator, you know how to do it. You multiply numerator and denominator by the offensive radical. This one you get to use your calculator on. So be sure your calculator is in degree mode when you use your calculator. Give it a try. We'll meet back and compare. Now, just because I get tired of switching between degrees and radians, I have two calculators. I have one that I keep in radian mode, and this one that I have the sticker on, I keep in degree mode, just to make my life easier. You'll probably just want to spend the money on one calculator and switch it back and forth. But I labeled hypotenuse, and then 10 degrees is my known angle. So A is op and B is adjacent. Sine is opposite over hypotenuse. So A is equal to multiply both sides by 12 and get an answer. Cosine is adjacent over hypotenuse. So cosine of 10 degrees is B over 12. So B is 12 times the cosine of 10 degrees. And I'm comforted by the fact that A is really short and B is longer, and it's still shorter than the hypotenuse. Hypotenuse is always the longest, but we have this tiny little angle here, and A is across from that, so we expect it to be a lot shorter than the one across from B. This is 90, this is 10. This other angle has to be 80 degrees. Let's see what we have next. Oh, lots of practice finding some opposite sides. So, let's do part A together. Find missing sides. And you can draw this any way you want to. So, I'm just going to draw a right triangle. It won't be to scale. I'm going to put A right here and B right here. And actually, those should be the capital letters because they're representing angles. We usually let the lowercase letters represent the side length, and the uppercase letters represent the angles. So B lives across from little b, and A lives across from little a, which is equal to 10. Cosine of B is equal to adjacent, and if we're looking at B, adjacent is little a here, which is 10 over hypotenuse. And we need to know what hypotenuse is. Hypotenuse is equal to C. So just so we have a variable, instead of the word height there, we'll do cosine of B is equal to 10 over C. But we know cosine of B, it's given to us. It's 4 over 5. So cross multiply. 4C is equal to 50, so C is equal to 50 over 4, which is 12.5, but I'm going to check just to be sure. 50 divided by 4 is, yes, indeed, 12.5. Sometimes I can do arithmetic in my head. So now I know adjacent, I know hypotenuse. I can figure out my other side in a couple of ways. I could either look at, I have hypotenuse, I have adjacent, I know what, let's see, let's just use the Pythagorean theorem. A squared plus B squared is equal to C squared. So 100 plus B squared is equal to 12.5. Can't do that one in my head. Squared. So b squared is equal to 12.5 squared. Equals 156.25 minus 100. So b squared is equal to 56.25. And we're going to go with a, let's see, I just plugged it into my calculator. We decided to just go with a decimal here, and luckily it came out to be a nice friendly decimal. So B is actually 7.5. I was trying to decide if we could do it by using cos or using sine, but we still only have the 2 leg lengths, so there wasn't a way I could figure out to do it without using the Pythagorean theorem. Give part B a try on how did part B go. So let me get it on the right page here, back to where we were. So we have sine of B was 1 over the square root of 3. We also know that sine of B is equal to opposite over hypotenuse, which would be B over C. So B over C is 1 over the square root of 3. So B times the square root of 3 has to be equal to C just by cross multiplying. A squared plus B squared is C squared. So just a little bit of plugging and chugging, and algebra, 4 plus B squared has to be 3 times B squared. So 4 is 2B squared. So 2 is B squared, and B is the square root of 2 because it's a length, and we know that, you know, if B squared is equal to 4 or 2, then B is plus or minus square root of 2, but it's length, so it'll be positive. And then C is equal to B times the square root of 3, square root of 6. So go forth and try part C. See how that one goes. I admit this one kind of surprised me because the number I got for A first was so big, and then the number I got for C was so close to the number I got for A. But that's because tangent is 100 and B is 100. Tangent is equal to opposite over adjacent, so A over B, actually A over B. So A over 100, so A is equal to 10,000, and then it's just a job for Pythagoras. So part D, give that one a try. Remember, 60 degrees is a special angle. So, of course, I drew my triangle. So sine of 60 degrees is square root of 3 over 2. But it's also equal to A over C. So A over C is square root of 3 over 2, but it's also equal to 5 over C because A was equal to 5. So I can solve that and figure out what C is. I know that cosine of 60 degrees is 1/2, so B has to be equal to adjacent over hypotenuse. And since this is hypotenuse, I can just solve and figure out what B is. Now we have kind of a challenge problem here. And I've already worked it, but since I want to go through it with you, I'm going to write it on my whiteboard here. So I have this big triangle, and I'm going to divide it into 2 pieces. So I'm going to start just by looking at this half of the triangle with a 36 degree angle, a height of 85, and I'll call this A. I'm going to do the same thing with the other half. I'll look at this half of the triangle. It's 85, and this is 50 degrees, and I'm going to name that B. And now A plus B will be equal to X, which is my goal, is to figure out what X is. So I think about my SOHCAHTOA, opposite over adjacent. So tangent of 36 degrees is equal to opposite over adjacent. So A times the tangent of 36 degrees is equal to 85. So A is equal to 85 divided by the tangent of 36 degrees. And now I have to get the right calculator, the one that's in degrees. And I just turn it on. We do fraction 85 over tangent of 36. And I get about 116.992. Same thing over here. Let's look at tangent of 50 degrees is equal to opposite over adjacent. I'm going to do all the same steps. I end up with B times tangent of 50 degrees is equal to 85. So B is equal to 85 divided by the tangent of 50 degrees. So, going to be super lazy. Change that from 35 to 50. And I get 71.323. So X is equal to plus 116.992. X is equal to 116.992 plus 71.323, which is 188.315. So we just had to divide it into pieces. It wasn't that bad. Wasn't that big a challenge, was it? So let's talk about angles of elevation and depression. An angle of elevation is where you start from a line of sight or a base level and you measure the angle up to something. So an elevation. Similarly, an angle of depression, you start at your base level and measure the angle down to something. We use these a lot in application problems. So let's do one. We want to determine the height of a tree. A person walks 30 feet from the base of the tree and measures an angle of elevation, so from their eye line to the top of the tree. Now with these, we don't worry about how tall the person is. We kind of assume that they're looking at it from ground level. We want to know the height of the tree, or they're measuring the angle from the ground. So again, I've done this one on a sheet of paper already, but we'll do it again. So I draw a triangle, right? Triangle trig, you're going to draw lots of triangles. So here's my triangle. This is 30 feet. This is the tree right here that we're trying to figure out how tall it is. So I'm going to call it H for height. And this is 57 degrees. So then you think about SOHCAHTOA. What do you have? Well, you have opposite and adjacent, so that's TOA. Tangent of 57 degrees is equal to opposite over adjacent. So H is equal to 30 times the tangent of 57 degrees. which means 30 times tangent of 57, 46.196. And don't forget your units, it's feet. And there's the pretty answer. It's rounded to 1 decimal place. Remember, do what WebAssign tells you to do. They want 2 decimal places. Give them 2 decimal places or you won't get the happy check mark. Okay, another practice problem. So this one is a little different because we have an angle of elevation and an angle of depression. So the radio tower is located 325 feet from a building. From a window in the building, a person determines the angle of elevation and the angle of depression, and we want to know how tall the tower is. So take a few minutes and see if you can sketch a graph of this all by yourself, because that's how you learn to do it, is by doing it. Once you get it all set up, so I put my window right here. It's 325 feet from this building to the tower. The angle of elevation to the top of the tower is 43 degrees. The angle of depression to the bottom of the tower is 31 degrees. So I really have 2 triangles here. I have this one, 43 degrees, 325, and again, let's call that A, just like we did on the problem we did a moment ago. Then we have another triangle with an angle of 31 degrees, 325, and we'll call that B, and then the height of the tower is A plus B. So give it a try and then we'll meet back and compare. Almost exactly like that challenge problem we did a moment ago. So we set up tangent again. Tangent of 43 was opposite over adjacent. So we end up with this piece of our height is equal to 303 feet. And then we did the same thing with this 31 degree angle. Tangent of 31 was B over 325, so about 195 feet. So the total, I just add them together, about 498.4 feet tall. Try this one on your own. We'll come back and compare. This one was a little different. Instead of knowing the distance, we knew the height of the monument. So a 400-foot monument is located in the distance. We have the window again. So I'm trying to figure out the D, the distance. So since I know that the height is 400, I kind of divide it into 2 pieces. So I let X be the distance from the height of the window to the top of the monument. So height of window to top. Well, then that means below there is 400 minus X. So I just drew my 2 triangles, and I like them so that the base is on the bottom. If you wanted to draw it like that, that's fine. It's the same triangle. Distance 18 degrees into X, distance 3 degrees and 400 minus X. So again, I have opposite over adjacent. So I ended up with a tangent of 18 degrees is X over D. The tangent of 3 degrees is 400 minus X over D. I have a system of equations with 2 equations, 2 unknowns. So X is equal to D times the tangent of 18 degrees. 400 minus X is equal to D times the tangent of 3 degrees. So I just added these 2 together because I have x and 400 minus x, that's the elimination method. My x disappears. I end up with an equation that only has d's in it, which was what I wanted to know anyway. I didn't really care what x was. It was just a vehicle on my path to finding d. So d was equal to 400 divided by the sum of the tangent of 18 and the tangent of 3, so about 1,060.1 feet. Okay, one more. Got a lightning rod on top of a building, kind of like practice 2, but again, a little different. Give it a try. So, instead of an angle of elevation and an angle of depression, we had 2 angles of elevation. One of them was 36 degrees, one was 38 degrees. So I called A the distance to the top of the building and B the length of the lightning rod. And we were trying to find the length of the lightning rod, so B was my goal. I'm going to end up with another little system of equations. So my first triangle is just to the top of the building. I was able to figure out what A was. And then I did A plus B to the height of the building plus the lightning rod. So A plus B, tangent of 38, is A plus B over 500. So I was able to find A. I was able to figure out A plus B. So I just subtract A from A plus B, and it gives me the height of the lightning rod. So sometimes you're going to have to use a little creativity to figure out, but right triangle trig, if you got a right triangle, it'll get you there.